at number 9 from last night's homework. On number 9, you have to use your answer to number 8. So for number 8, the answer was 1,700 pi cubic feet. That's how much that cylindrical tank can hold. It can hold that many cubic feet of whatever you're putting in the tank. How many cubic yards are contained in the tank? And I like this problem because there was a problem on your test that made you convert from feet to yards, from yards to feet, right? And it was a 2D problem, and this one's a 3D problem, so that makes a little bit of a difference. All right, we are going to learn this on Wednesday, but I'm going to go ahead and jump and kind of ruin Wednesday's lesson by teaching you how to do this one here. Now, I want to convert this from from feet to yards, and there's 3 feet in 1 yard. So I'm going to take my answer from number 8, and what am I going to divide it by? So here's the hint. If I was, let's say there was a length, and that length was, I don't know, 24 feet, and I wanted to convert that to yards, I would just do 24 divided by 3. That would be 8 yards. 24 feet is 8 yards. I just divided by 3. But those were lengths. This is a volume. You can't just take a volume and divide it by 3. This does not say 3 feet cubed equals 1 yard cubed. So how could I take this conversion and make it not 1D, not 2D, but 3D? Thank you, Ralph. Yes, if I wanted to make this 3D, I would cube it. Cube it. What's 3 cubed? You know how to do that on your calculator? What's 1 cubed? Kind of weird. I know that's really weird, but I promise it works. So I'm not going to divide this volume by 3 because it's a volume. I'm going to divide it by 27. And that is actually the answer. But if you wanted to write it as a decimal, you could press pi and you could actually divide it. 1,700 pi divided by 27, divided by 3 cubed. So this is approximately, not equal to, but approximately that many. Oops, sorry. Whoa, watch out, Miss Stanton. Sorry, we converted it to yards. Cubic yards. Cool. So your answer could be 1,700 pi over 27, or it could be 197.8 cubic yards. Number 11, what's the total surface area of a cylinder with an altitude of h, an altitude of 8. I was getting ahead of myself. The altitude and the height, those words are interchangeable in these problems. So the height is 8 and the volume is 200 pi. So this is a work backwards problem. Let's write the formula for volume of a cylinder. Pi r squared h. I'm going to take h and I'm going to put 8 in its spot. The pi's cancel, so I have 8r squared equals 200. Divide by 8, and then square root. R squared is 25, R is 5. I'm going to stop right there. I am, and I'm going to let you finish off that formula. The last one you asked me about was number 15. Water is running into a right cylindrical tank. That just means it's not the Tower of Pisa. Right cylindrical tank just means it's not oblique. It's not leaning over. At a rate of 5 cubic feet per minute. That is good news because they gave it to us in cubic feet already, so we don't need to convert anything. This is going to be really nice. How long will it take to fill a tank 8 feet in diameter and 5 feet high? What I'm going to do is I'm going to skip forward and give you the volume because I know you can plug numbers into a formula. The volume with the pi button pressed, yes, I pressed pi, so yes, that is an approximate, not exact, because this is a real world problem. We want to find our answer in minutes, okay? So this is the volume of the cylinder. Okay, now they're going to start pouring the water in, and they're going to do it at a rate of 5 cubic feet per minute. What's cool here is that the units cancel. What units are left when my cubic feet cancels? Minutes. That means our answer is going to be in minutes. So that's really cool. That kind of affirms that, hey, we're doing the right thing by dividing here. So you take that volume, you divide it by 5, and you get, it's going to take about 50 minutes, a little bit less than an hour. We have 2 lessons in one today. We're going to start with cones. So title your notes, surface area and volume of cones.